Now we're done? Alrighty. Related rates process is as you see, draw a picture unless it's a known figure, which it is in this case. Establish what is being given in calculus terms and establish what they want and when they want it. An equation for what they want and when. Differentiate with respect to time. Sub and solve. Okay. Another minute? One more minute? Okay. Taya, what's being given? dVdt is negative. How'd you know it was dVdt, not dxdt?
Because of the units.
Right. Excellent. Okay. What do they want and when do they want it to be?
They want it.
Oh, they want how fast X is changing.
Okay, so
Or like how fast when X is changing.
all right.
When the volume is 10.
Okay, perfect. All right. What equation did you use, Mr. Hughes?
I don't know.
Okay. Help me out. What equation? Yeah, volume is x cubed. This is volume of cubes, so let's go x cubed. Obviously, you don't want to overcomplicate it. Area of the base times height is unnecessarily complicated. Volume equals x cubed is better. Yeah? Yes? Volume and cube. So, if you're thinking, why not area of the base times the height? Now, that's a sort of logical question. Why is x cubed better than area of the base times the height? How many variables in volume equals x cubed? Volume x. That's 2. Okay. How many variables in volume equals area of the base times the height? 3. Volume, area of the base, and height. Okay. So that's why we chose x cubed. In this case, it's a known geometric formula. Ms. Harrington, hit me with the derivative on this when I differentiate with respect to time.
I'm really confused.
Okay.
So,
Are you with me up to there, or do we need to go back?
I got that far, and then
Okay.
after that I don't know what to do.
All right, Mr. Cronin, differentiate with respect to time. Okay, so when you differentiate with respect to time, first of all, in a related rates problem, you're always going to take a derivative with respect to time, not x, like we do in a lot of other problems. All right, so these are time-related problems. When you take derivative with respect to time, you take the derivative of the function, which in this case is just 1, but then times the derivative of the variable itself. So this really is 1 dv/dt, but obviously dv/dt is just fine. When you take the derivative of this side, it's the derivative of the function, which is 3x squared, times the derivative of the variable. Chain rule, really. And so 3x squared dx dt, are you down? All right. Now it's up to you. You have 2 things to do. Either substitute stuff in, then solve, or solve, then substitute. Mr. Perlman, do you want to substitute first or solve first? Okay. I can plug in -5 there. And in place of x, I have, I don't know what to put for x, yeah? So sometimes you're going to run into a problem in substituting because they'll kind of give you a implied thing you need. If volume is 10, what does that imply about x? It implies x is cube root of 10. So you actually had to do a little hunting for that one. Cube root of 10, and dx dt is that which we are to find, okay? So dx dt could be something as ugly as negative 5 over 3 cube roots of 10 quantity squared. I have absolutely no problem leaving it with that. I just want the units. What are the units? X, so that's just centimeters, right? Is that all then? Centimeters is it?
No.
Okay, what are the units on the whole thing?
Centimeters per hour.
Centimeters per hour is change. It's a rate of change, so it should have x units and time units, centimeters per hour. Down. Okay, now, if that didn't go well, or if you had trouble with those in the homework, I kind of have bad news, because it's about to get harder, okay? So, here we go.
Today?
Yeah, today, right now. All right.
Today, right now.
So, would you pick up part 2 of your related rates notes? They are
I hate all
the,
this is very
so it's the one that's titled, it's titled Set 46 Related Rates 2. Okay? Okay, so what makes this harder is 3 variables. So look at this, for example. Liquid is drained from a funnel at a rate of 2 cubic inches per second. How fast is the liquid falling? I imagine that's the height. When the liquid is 7 inches high. Now I remind you of the steps, and this step is going to be a little more yeah, actually I don't like those steps. Never mind, erase them. All right, so let's go here. Let's talk about what's given. What is being given? The given is okay, so you're given the picture. I don't require that you state the picture stuff, though the diameter is 12 and the height is 10. Now keep in mind, that's of the cup itself, not of the fluid within. Okay, so differentiate between the cup, which is constantly 12 and 10, and the water within, which is still of the same shape, but differing in volume and height and so on. So what about the calculus fact given? Ms. Athmary, what do you make out of rate of 2 cubic inches per second? What is that in calculus? dVdt, wonderful. Okay, so dVdt, and do you reckon dVdt is positive or negative? It's negative because volume of liquid is draining out, volume is decreasing. So your given fact is dVdt is 2 cubic inches per second in a negative way. You with me on that? All right. What do they want and when? Now, this is where we might need to doctor up the picture here. This, in terms of the water will have a radius and height that's changing. So I need to make them variables. They're going to change. The 12 and 10 are cool because they're not going to change, but the water within, those are going to change. So make them variables. And now, what do they want? How fast is the liquid falling? Is that change in volume, change in height, change in radius? Yeah, that's where this level is, and that's height. So they want the HDT, and when do they want it, besides now? When the height is 7 inches, right? Okay. Now, up to there, we are pretty much the same as usual. Get a picture, establish what they want, and when, and the givens, and so on. And we're still going to do an equation. So what's the equation that we would use for volume changing in a cone form? Volume is 1/3 IR squared H. Okay. Now there are 2 ways to go about this. One is to substitute down to 3 variables then take the derivative. What I'm saying right now is that I have three variables: volume, radius, and height of the water. If I could substitute to get down to two, the calculus usually goes a little better, because then I don't have to worry about the product rule like I will. So what is an other relationship to substitute? Look for an other relationship that you can use to substitute. This is one of those hard parts, because every problem is different. Is there any relationship between the radius and the height besides the cone volume? Triangles, beautiful, okay. So although the water is different than the cup, they are the same shape if I cross section, yeah? So the ratio of the radius to the height should always be consistent with the cup shape. 12 to 10? 6 to 10. 6 to 10. Do you agree? Because it's got to be the radius we're talking. You follow? Okay. So by that, I could say that R is to 6, as H is to 10. Now it's up to me to either solve this for R so that I could put that in and make all H-ish equation, or I could solve this for H and substitute in so the equation is all R-ish. Which should I do? Solve for R and make it all H-ish? Why? Because that's what you want H. I mean, you have facts about H. You want H. You want the equation to be all H, not R. So in terms of what you're going to put in for, you want to put R is 3/5 of the height into the equation, so that this equation, instead of depending on R and H and have this terrible product rule derivative, can be rewritten as pi over 3, R squared is cool, and I'm looking at maybe 3H over 5. So you're saying I am dumb. Is that what you're saying? I feel like you're saying I'm dumb. You're right, sorry. So in place of R goes 3H over 5, and H stays. Good call. Way to pay attention. That's just testing you. All right, you passed. I get 9H cubed over 5 or 25? 25. So maybe as clean as possible, I'm getting 3 pi H. All right, let's go big coefficient, okay? So what's the total of all the coefficients or all the numbers, please? Clean it up for me, please. The numbers out front first. 3 pi over 25, and then just straight up H cubed. Okay, so trying to make my derivative nice and clean, and that's done best if the numbers are nice and clean up front, and the H is next to it, and we're ready to go. You with me? Okay, great. Am I done? Do I circle it? No. Now we take the derivative with respect to V, H, R, T, T. It's how things change with time. So differentiate with respect to time. What's the derivative of V with respect to T? dV dt. When I take the derivative, do I need to do the product rule over there? Or no, that's just a coefficient. I can just stick it up front. Just stick it up front. It's a coefficient, 3 pi over 25. And I just focus on taking the derivative of H cubed with respect to time. What's that? That's true. I see where you're coming with 9. 3H squared d dH dt, which you can see where she's saying 9 from. You follow? All right. We need to now sub and solve, or solve and sub. Do you want to put stuff in now and then solve, or solve first then put stuff in? Put stuff in first. Okay, so what can I put anything in for dV dt? That's -2, yes. And I am going to do that 9 pi over 25 thing. And what goes in for H? 7. And what goes in for dH dt? Nothing. That's what I'm looking for. Okay? So dH dt is something like -2 equals, so I got your 9 pi times 49 all over 25 dH dt. I don't know if that was really necessary, but what the heck. All right, so solving for dH dt is -50 over 49 times 9. Mentally, no calculator, you leave it. 360 plus 81, so 441, yeah? Get that mental exercise, baby. All right, what are the units then? The pi's down there.
Oh,
Inches per second. Does that make sense that dH dt is negative? Why? Yeah, as the volume decreases, as volume drains out, the height will decrease. A negative derivative means a decrease in the thing you're talking about. You with me? Okay. Now, that's a fine answer, and I guess we can move along, but I would like you to see the consequences of not doing that substitution, right? So we're going to do the same problem, but a slightly different way. If we took the derivative with 3 variables and substitute later. So if you start with saying volume is 1/3 pi r squared h, and you're just so excited to do your calculus that you said, I'm going to do my derivative now, all right? So if I take the derivative with respect to time now, then what is the derivative of v with respect to t? dv dt equals pi over 3. Do you want to lump pi over 3 in with the r squared, or leave it out front? Leave it out front. Okay, so pi over 3. Now, by product rule, derivative on r squared h with respect to time. So first stays the same, r squared, times the derivative of the second with respect to time, dh dt, plus second stays the same, h, times the derivative of the first with respect to time, 2r dr dt. This gets messy. Obviously, you have to be great with details, which is a good skill to develop in yourself. All right, so now let's do some substituting. Can I put something in for dv dt? Yes, I can say that dv dt is -2. Pi over 3 is fine. Golly, so what about the radius? Very common problem. Somebody would say the radius is 6. True or false? False, okay. What does r in this problem refer to? The radius of the water, not the cup. Okay, the cup was not interesting at all. Does the cup even have a rate of change? No, the cup staying, that's not calculus. That's stupid, okay? The water is the one that's changing. So r is a reference to the radius of the water, not the cup. The cup is not a radius, or the r is not 6. So the problem then is I don't know what the radius is at the instant. I'll have to come back to that. dH dt, that's what we want. Do you agree? And I do know h is 7. Once again, I run into that don't know the r. And do you know dr dt? No. So you just are running into 2 different problems. Don't know the radius, don't know dr dt. Much harder to do. Either way, you're going to have to get some other fact about r and h. So whether you do it earlier like we did here or later like we're going to have to do here, you're going to have to go and get that other relationship. So you still are not going to be able to avoid this similar triangle idea that we talked about over here, that the radius is 3/5 of h, yeah? You with me? Okay, now, if I have that fact, then can I find r at the instant? When h is 7, what's r? 21/5, right? So I could put that in there and I'd say, okay, R is 21/5, and that also goes here, 21/5. So at least now I've got that. You with me? Unfortunately, I still don't know dRdt. What's dRdt? Now that I have an RH relationship, what's dRdt? So if R is 3/5 of H, then dRdt is 3/5 of dH dt. I guess I could put that in there and say, oh, 3/5 of dH dt. Now at least do I have a chance. Yeah, at least now it's dH dt only, and I could go and if you want, we can continue on and show that that's the answer. But, or if you want, you can just take my word for it that that is what we'll arrive at. We'll still get the same answer. But my point is this, which is a heck of a lot easier and less likely to lead to mistakes. Substitute early or substitute late? Yeah, substitute early is way easier because the calculus is way easier, and then instead you don't have to take this product rule and another derivative later. You've got to substitute early when you have three variables, okay? That's the point of that. So let's try one. So solve a related rates problem when the given and the wanted are indirectly related through a third variable. And then we'll also do maybe another three variable problem on the homework. We'll see. So Isabel pours salt onto the table at lunch. What a wiener. At a rate of pi over 3 cubic centimeters per second. Now, when you pour salt onto a table, it forms a cone. And the shape of the cone actually depends on the viscosity of the material, how big it's wide or narrow and all that stuff like that. But that's okay. The radius is equal to the height in this case. I definitely threw you a bone there, whether you know it or not. That's delightful. At 8 seconds, how fast is the lateral surface area of the cone changing? Yeah. Okay, so I've got a picture. The lateral surface area is something else entirely, and I got some givens. So I think I understand my variables. Let's start with the givens. What do you give? Do you want to give us a go on your own?
No.
You're supposed to say yes.
No. I just don't know how to do it.
Come on. That's it. It's you grow by flailing around and failing.
Okay, let's
Small
do
flail.
it.
All right. So I'm putting you under the bar at 400 pounds. Bench it, baby.
No.
Okay, well then at the very least, then let's.
Are you trying to kill us?
Crush, go.
If I did it right, you should have no testing.
You should, and then you should walk around saying, I can bench 400 pounds.
Now we can use our formula.
Do feel free to work it over, talk it over with your math amigos. Are you talking to me? Oh.
I don't know. Yeah, I know. Surface area is 4.
You guys are the worst. Lateral surface area is area of the base plus 1/2 the perimeter. What is it? Pi. Actually, I should remember. Area of the base plus pi RL. So pi r squared plus pi RL. Wow, this is a humdinger.
Oh, do it yourself.
Yeah. Are you dead yet? I could not, but I could do this problem. That's the spirit.
Lateral surface area
Sorry, it's just, lateral surface area is just pi RL. Sorry, total surface area is pi R squared plus pi RL. Pi RL. LSA is pi RL. Sorry, apparently I'm the worst. Total surface area is pi R squared plus pi RL. Lateral surface area is pi RL. I don't, are we? You should at least be able to tell me what's given and what you want.
I do know that. This is literally my goal. Wait, I need to know why are they giving volumes? Because you like R, you just plug in L. What?
Now you're talking.
R one at any point in your life. You have to find R, but then you use is it one though at any point? Yeah, you use volume. I use area and volume. Why are you volume over? No, it doesn't. I just use the volume. Yeah, but we use the volume. Yeah, but then you can't find R. Because you also use R.
All right. I'm going to start working. Have an answer by the time I'm done. Fine. Take it step by step. Whoa, this is really hard.
Yeah, you do like 12 points. How did you get that? I got one.
One? Is it that clean? I'm almost done.
He's almost done. Hey, you know what? I did everything. What do they even do?
So I found it, but I didn't use it again.
Oh my god.
My answer is pi root 2 over 3.
Yeah.
That's what you got?
No.
Yeah.
That's what right out,
This might have been too much at once, so that's all right. Well, this is not what the fun sheet will be like. I gave you the easy ones for your fun sheet. So, what's the UDT?
Pi over 3.
Pi over 3 cubic inches per centimeter, or cubic centimeters per second, right? Do you agree we want the ADT at time equal 8? Okay? We'll have to come back to that because at time equal 8 doesn't tell you a whole lot. We'll need more. So, make a plan here. I know there's not an equation of volume related to surface area. So, what do you reckon you have to do? You have to use the volume equation to find the derivative. How? What changes? You could find use dV/dt to find the RDT. And then once you know how the radius changes, could you use that to find the surface area? So you'll have to take two equations, right? So let's start with volume. Do you agree that volume is pi over 3 r squared h? Okay, so pi over 3 r cubed. Why? All right. That was pretty nice. You're welcome. Okay. now we're ready to differentiate. What's the derivative with respect to time?
Pi r squared dr dt.
All right, now that was probably the first place you ran into trouble, right? Not the, you got that far, right?
Yes.
Okay, now then, dv dt is given, that's okay. Pi is obvious. The problem though is what is r when they talk about. Now that's r at the instant, and the instant they give me is more like time equal 8. So yeah, how big is the cone? I assume there was no salt in the table at time 0. At time equals 0, the volume is 0. At time equal 8, what was the volume? 8 pi over 3. It comes in at pi over 3 every second. For 8 seconds, the volume would be 8 pi over 3. That's equal to pi over 3 r cubed, yeah? Do you agree? Okay. That implies that at 8 seconds, the radius of the salt pile is 2. Now we know that, we can find dr dt. So dr dt is, pi's drop away, what do you get? 112. Okay, normally I'd say units, but we're going to use that, so don't worry about the units, although it's probably centimeters per second. Okay, now let's talk surface area, or lateral surface area. It's pi rl, yeah? Okay, so should I take the derivative the way it is, or is that free variable sub to get it to 2? Sub to get it to 2. Draw yourself a little picture here. Here's the slant height. Here's the radius. What else? And the height, but that's also equal to the radius. So what's L equal to? Or root, or 2r squared, square rooted, so root 2r. Okay? Now I can say the lateral surface area is pi r times root 2r. Okay, or pi root 2r squared. We're oh so close. I'm just going to shorten it down to a. All right, now what do we do? Take the derivative with respect to time. The ADT is pi root 2 times 2r dRdt. Pi is pi, root 2 is 2, root 2, 2 is 2. What's r? 2, remember we found that earlier with the salt pile, what 8 seconds is 2 radius. dRdt is 112. Found that also just now. So dAdt is something like 4 goes into 12 times, so pi root 2 over 3 units. Centimeters squared per second. Don't you feel like a sense of accomplishment? Oh. Together we bench 400 pounds, man. Come on, that's great. All right. That should get you going on the homework, or you still won't be terribly. Do you still have 45?
Yes.
Let's at least get 45 knocked out and move on from there. Can you tell me what questions you have on 45? 24. 15. Boy, that's the long one, I think, yeah? Make sure you give me questions on 45. I'm talking to you the long one, not 46. Okay, 15's a replacement. Good call. 24 is not a replacement. Shucks. Okay. So Okay. All right, so 15. P of 20. P of 20 is, what'd you get there? Something like, oh my goodness, that's a mess. 20, what is that? Something decimal-ish? Somebody give me a decimal approximation of P of 20. Does it come out clean? Surely not. Anybody? 4.18? No? 151. I'll take it. Okay? Interpreting this, please. P represents at a certain time how many problems you have done. All right? So you would say at time equal 20 minutes, I have done a little more than 4 problems. Yeah? Do you agree? You with me? Okay. P prime of 20 is definitely calculator active. P prime of 20 is approximately, somebody who did this, 0.271. Okay? Now, it helps me to interpret a derivative by thinking of it as a rate instead of P prime notation, or like dp dt. So that's change, D stands for delta, change in problems over change in time. So at time equal 20 minutes, I am doing problems at a rate of 0.271 units. dp dt, problems per dt, minute. Okay? At that point, I'm doing problems at roughly 0.271 problems per minute. You follow? Okay, 24. Is that a replace? That's the book problem, right? Okay, so I will add a 24. If we have time, we'll go over the other replacement answers. 24 on 45. Yeah. So okay. So what's a backup? If you can't, if you know, hey, I know there's a formula, but I can't remember it, what's a backup? Just grit your teeth and just chugging it out, right? So could you, I mean, it's if it says 20 terms, is that doable? Yeah. If it said 300 terms, are you doing that? Probably not. Okay, so one possibility is just crank out terms, 10, 13, 16, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Now, even if you have that, then you still have to decide, all right, should I add these stinking things, or is there a smarter way? There is a smarter way. You remember what the smarter way is besides not knowing the formula? Think rainbows, okay? So if you add those, what do you get? 53. If you add these, what do you get? 53. If you add these, what do you get? So each sum working in is 53. How many sums? 10. So the sum is altogether 530. That's one way to do it. That's the way I would do it because I don't remember formulas very well, and it's I just hate looking up formulas. I'd rather think it through myself. If you were to think it through yourself, great. If you wanted to remember the formula, the idea is that the sum is the sum of adding the first and the last, that's those rainbows, and multiplying it by how many. The problem, though, is what is a sub n? Well, the 20th term comes from taking the first term and adding 3, how many times? Yeah, 19 times. So the last term, you could jump to it without all this stuff by saying, well, it's negative 2 plus 3, 19 times, that's 55. Now you can say, oh, so the sum formula is the first term, negative 2, plus 55, or basically 53 for each rainbow, times the number of rainbows. Okay? Please don't say that rainbow stuff in college, that's not real now. All right. Go to, do we want to talk about any of the other back replacements? What'd you say for this multiple choice? True or false? You can count the zeros to determine how many extrema. It's not enough to be 0. That's a horizontal tangent, but could it goes back up to increasing or decreasing? So it's not enough to be 0. The derivative has to change signs. Okay, so how many places does the derivative change sign? There are 3. This one's positive to negative, so that is a max. This one's negative to positive, so that's a min. And this is positive to negative, so that's a max. So it should have 2 max and 1 min. Your answer is B. Okay? 8. The first derivative is you are expected not to take the derivative by hand or even try and solve this by hand, but to graph this and find how many places is f prime 0 or undefined on 0 to 10 in your calculator. How many times did the derivative hit 0 or undefined from 0 to 10, not inclusive of the endpoints? 7?
I don't know.
I don't either. I didn't actually do this. This is a blank paper. I don't know the answer. 7, 6? It could be lots of things. Can you tell me what it is? 6? 5? I was really hoping for just a consensus. Can we graph that, please, and set your window? 3 sine of... Ay, ay, ay. You guys are the worst. 3 sine of 2x over x squared. This is the worst class ever. Yeah. Come on, darn it. 5? Come on, see what you get. What did he say? Isaac Lee? He's not even in this class.
But he's been in BC, so he must.
Yeah, did he do the problem for you or what?
No, not me.
Oh, somebody else.
No, not anyone.
No. Divided by x squared. Ay, ay, ay. 0 to 10. 0 to 10. Negative 1 to 1. Ay, ay, ay. 1, 2, 3, 4, 5, 6. It helps if you not only set your x window to negative or 0 to 10, but set your y window really tight around the axis, so if it's just barely above, you can see it.
How would you do that without a calculator?
Okay, so you would have to say, where are the zeros to this and this? That's 1. So you would say sine of 2x needs to equal 0. That's sine of 0 at 0 and pi and 2 pi and 3 pi and 4 pi and 5 pi and 6 pi, etc. So x is 0, that doesn't count, pi over 3, 2 pi over 3, pi, 4 pi over 3, 5 pi over 3. You keep going until you got to 10. You'd have to take some guesswork. When am I at 10? So that's a way you can do it analytically. Okay? 10, ooh, that was loud. 10, what'd you say? 2 zeros on -5, which is increasing. So, this is a great gotcha question. Do you say increasing on this region from -1 to 1? Is that a choice? No. Darn it, that's too bad because that's the best distractor. Okay, let's, oh shoot. 45, yes, 46, you can keep. Have a wonderful weekend.
Actually, no,